Okay. Hello everyone. I express my warm welcome on behalf of Tagore Engineering College from the Department of Computer Science and Engineering for the online webinar on Big Data in Digital Marketing. Now here we have Mr. Deepak Paneerselvam with us, who is currently working as architect in Barclays. Mr. Deepak has worked in various phases of project life cycles in the areas of big data, machine learning, web development, and software programming. His areas of interest are artificial intelligence and blockchain. Now he's here to share with us the multiple aspects of big data in digital marketing and how it can be implemented using various software techniques. Now I hand over the session to Mr. Deepak. Sir, the session is yours.
Yeah. Hi, everyone. My name is Deepak. I thank HOD and staff members of Computer Science and Engineering Department. Yeah, let's start. So what is big data? So big data is the field which is used to process the massive amount of data. When I say massive amount of data, it means petabytes and zettabytes. So this data includes both structured, unstructured, and semi-structured data, so that it is so large and difficult to process using traditional database and software techniques. I mean the old traditional way of doing the software. So in the most enterprise scenario, the volume of data is too big, or it moves too fast, or it exceeds the amount of processing capacity. So the big data will be the next big thing in an IT. So there are like a lot of organizations which embrace it, where online and startup firms already, a lot of companies like Facebook, Twitter, LinkedIn, eBay, and so other companies have built around big data from the beginning. In fact, one of the biggest India's big data project is Aadhaar card system. So Aadhaar card store all the customer informations of the Indian citizens in the big data based ecosystem. So moving on to the next slide. So this slide I will talk about old model versus new model of generating the data. So in the old model, only few companies are generating the data and all others are consuming data. I mean, few companies in the sense only media companies and the classifieds like Yellow Pages were collecting the data, and rest of all the customers are just the consumers. So, but in the case of new model, everyone is generating the data and all of us are consuming the data. In fact, if you see Facebook is generating more than 100 terabytes of data on the daily basis. The same is applicable for Twitter also. So thanks to the big data technologies and the sophisticated open source technologies built on the top of big data based solution. So we will discuss some interesting facts on the big data. So overall 90% of the generated in the world was created in the past 2 years. If you see before, like in the last decade, most of the big technologies are not open source. It is available between the closed loop across the companies. But once the big data became open source, like a lot of companies started adapting big data. So which created a lot of companies start creating the data. So another interesting fact is by 2020, the digital information in the existence will have grown from 3.2 zettabytes to 40 zettabytes. It's somewhere around 10 times the existing market scenario. With the COVID-19 in place, like a lot of companies are trying to do the digital transformation. So a lot of small companies, they are started doing e-commerce. So which will open the market for the big data. See, the total amount of data being captured and stored by the industry doubles 1.2 years. It is just the rough estimation, but by considering the current situation, so the volume could be more than the anticipated value. So if you see the current scenario, every minute we are sending 204 million emails and generating 80 million Facebook likes, and sending 278,000 feeds, uploading around 2 lakh photos to the Facebook. This is kind of rough estimation. So the big data solves the problems of storage, scalability, fault tolerance, and availability. So another interesting stuff is Google alone processed 40,000 search queries per second, making it over 3.5 billion in a single day. So when I talk about the big data, so the important thing is the characteristics. So we can simplify the characteristics as 3V. 3V stands for volume, velocity, and variety. So what is volume? So if you consider like few decades back, the typical personal computer or desktop will have like 100 gigabytes or 10 gigabytes to 100 gigabytes for storing the data. So, but if you consider the current scenario, even Facebook is ingesting 500 terabytes of data every day. The same is applicable for other scenarios like Boeing 737 flight is generating 245 terabytes of flight data for a single flight across the US. So if you consider the whole market like IoT, machine-to-machine economy, where machine-to-machine communicate with each other, there is a large scope of collecting various volumes from all these insights. So big data helps to address the the problem of volume. Considering other scenarios like smartphones, sensors, embedded systems, and if it's geospace, be other data feeds from social connector and content creators like YouTube, Twitter, everyone is generating a data, right? So big data, using big data, so we can collect all that information and persist that information using the scalable storage system. So when I talk about velocity, it is nothing but the speed. So speed is important, very important for running any application. For example, if you're doing some shopping in the e-commerce, so the customer wants like seamless experience. They want kind of quickness in each and every actions. So big data helps to solve the problem of speed. So considering the some scenarios like stock trading, high frequency stock trading, so we can get the response within nanoseconds or microseconds. The same is applicable for click streams and ad impressions. So when you talk about machine-to-machine economy, where machine talks to each other, for example, consider the autonomous car or self-driving car. So for self-driving car, it has to get insight in the real time from the large storage space. So that storage space problem will be addressed by big data, and the speed which it can, which it needs to process the data also will be solved by big data. So other areas are online gaming industry. So the next is variety. When I talk about variety, it means like what format of data you are dealing with. So big data is not about just the numbers, date, and strings. It is all about different kinds of data like structured data, unstructured data, and semi-structured data. If you consider traditional databases like Oracle, MySQL, Postgres, it stores only structured data, meaning it will have a specific schema. You have your database, you have your table, and you persist all that information into the database. It actually deals only with the structured data. But when you talk about big data, you can, the variety is unlimited. You can store any sort of data like MP3 files, image files, the click streams, different types of data like CSV format and 3D data, audio, video, log files, social feeds. Every data can be persisted in big data. So hence it solves the problem of variety. So another aspect is how you are storing the data in the big data. So first you have to analyze, the data characteristics. For example, if I want to pull the data from IoT devices, so you have to identify, what are the different data sources that needs to be analyzed. Like, the data source could be an IoT device, or the typical application files, or social data from Facebook, Twitter, and streaming contents from YouTube, etc. And eliminating redundant data. Redundant is nothing but you have to eliminate all the duplicate data before persisting in the big data, because eliminating duplication will avoid redundancy of the data. So considering the overview of big data stores, there are like multiple data models like key value, graph, document, and column family. The typical example for graph is friend of friend suggestion. So most of them have used Facebook, right? Facebook does kind of friend of friend recommendation. So it is something like a social graph. So friend of friend list. So you have graph, recursive graph kind of thing for each entity in the graph, right? It's a more of a graphical representation of the data model. So in that scenario, they use graph scenario. And another scenario is key value storage. For example, if if it is an Aadhaar card based system, so Aadhaar card number will be a primary key. So Aadhaar card number in this case will be a key, and the value will be the corresponding attributes like age, location, address. They store that iris, fingerprint, every information as part of value. It's document, meaning the catalog information, product catalog information. For example, for under a specific product, for example, mobile and accessories, you have a mobile, you have a scratch card, and you have a charger, earphone, earbud. There are like so many categories are associated with the accessories, mobile accessories, that can be stored as a catalog. In that scenario, you will go for document storage of big data. And another main thing is the Hadoop distributed file system. So HDFS is the simplest form of Hadoop distributed file system. So it actually stores all the data. So another data store is Hbase. Hbase comes under the column family, where you store you can store both structured and unstructured data. And if someone is not comfortable with any of the programming language, mostly for the database, in the database aspect, if someone is very comfortable with the SQL query, they can use the high SQL data store to ingest and query the data. So moving on to the next slide. So depending upon the use case, you have to choose the right data store. For example, if if your business needs like a lot of key value storage, you can choose a key value model. And if you have like a lot of catalog information like e-commerce and online shopping kind of thing, you can use document storage. And you have to analyze different characteristics of the data. From the data, what sort of information you want to extract and persist into the system. So you have to classify that information, and you will be writing some small piece of code to move the data back and forth between the data store to the application. So, and another interesting aspect is polyglot data storage solution. So for example, someone will be comfortable with Java, and a few will be comfortable with C#, Python, Scala. There are like different languages are there. So we can use any programming language to store and retrieve the data. Even if you're not comfortable with SQL, all these programming languages, still you can use SQL queries to ingest and extract the data. So that is the beauty of the open source and the technology stacks around the big data solution. So the next thing is you have to align the business goal to the appropriate data store, so that you can monetize the data. So I'm just I have given some real-time examples of digital marketing using big data. So most of them have used Amazon. So Amazon does kind of recommendations based on your previous browsing history as well as the purchase history. For example, if you buy a mobile, it do some recommendations on buying the scratch card, or it recommends similar products of the mobile, and even it recommends accessories also. It's all based on the browsing pattern and the purchase history. So for doing the recommendations and the prediction, they store all that information in the big data store. See, another classical example is movie recommendations in Amazon and Netflix. Even for Netflix recommendations and Amazon Prime's recommendations, the underlying data store they use is big data. So Netflix actually recommends movies based on your previous history and also your previous choices. For example, if you're interested in some action movies, it just keeps on recommending the action, similar kind of action movies. So it's not only for the larger enterprise. Even big data can be used for smaller business to improve their monetization aspect. Like a lot of companies adopted big data to promote their related products. So it's kind of promotion and cross-selling aspect. For example, if they are buying a book on a PMP project, and it just keeps on recommending the product which is similar to their goals. So now I will talk about the technology behind the big data. So as I said, there are like multiple technology, open source technology frameworks and stacks are available to implement the big data. And Hadoop is the leading open source technology to implement big data based solution. So we will cover various aspects like what is Hadoop, very different types of Hadoop application. We will focus on high level overview of Hadoop architecture, what is the importance, advantages, and when to use Hadoop, right? So Hadoop is actually the open source Apache open source framework written completely on Java that is used for parallel distributed processing. So if you see the traditional software application, you just run the software or execute the piece of software programs in a single physical machine. So there is a problem. For example, today you have 100 GB of data and your business grows, right? Within 2 years, your business increases somewhere around 10 times, right? So now you need, instead of 200 GB, now you need a terabytes of data, right? So this keeps on growing linear. There is a linear growth in the data as and when the business grows, right? So that is a considerable amount of, there is a need for scalability in your system, right? So what you do whenever in the typical computer, what we do, for example, within out of 200 GB, you just keep on external hard drive to just add, to increase the volume of data, right? So you call this as a X scaling. So you cannot scale your PC after certain level, correct? So here, here is the place, where you need a Hadoop. So instead of just increasing a hardware or software in a single node, what you do, you will have a list of commodity softwares which will form as a cluster. Cluster in the sense a group of computers will form a cluster. So the big data Hadoop is aimed for distributed parallel processing. Instead of executing a program in a single machine, the big data Hadoop will execute in a group of computer. It will distribute the workload across all the nodes in the cluster. So it is mainly used for distributed storage and computation across clusters of computer. So there are like multiple components of Hadoop, which includes a name node, secondary name node, job tracker, task tracker, and the data node. The data node actually stores the data. The data is distributed across multiple nodes. And name node store all the metadata information. For example, you have like 100 terabytes of data and you have 5 physical machine as part of your node. So it will just name node will have the metadata information, like where that information is persisted, right? And job tracker is responsible for scheduling the load across multiple nodes. And the task tracker is used mainly for executing the process, so that the load will be either stored or retrieved. It is mainly used to run the typical ETL job, extract, transform, and load kind of thing. So Hadoop is actually a sub-project of Lucene under the umbrella of Apache Software Foundation. So it is, as I said, Hadoop mainly used for parallelizing your data process across multiple nodes instead of doing it in a single computer cluster. So which the main advantage is it increases the concurrency, parallel processing, and speed up the whole computation process. For example, if you are running a ETL job in a single machine for 10 hours, with Hadoop, with Apache Hadoop, it is 100 times faster. So within, instead of 10 hours, you can do even within 10 minutes. So it is that much faster. So there are like multiple applications that we can build, using Hadoop. So Hadoop can be accessed by a number of ways. You can use, various programming languages. You can use like queries. Depending upon your choice, you can create an abstraction layer on top of the Hadoop. So these are the different components of the Hadoop framework. MapReduce, Hadoop distributed file system, Yarn framework, and common utilities. MapReduce is the programming model to store and distribute the data across multiple nodes. And HDFS is the distributed storage. And Yarn is the latest framework of the Hadoop ecosystem. And the common utilities are nothing but the common operations that you do with the storage, something like input, output, access, and various converting from one format to another format. Everything can be done with the common utilities. So why is Hadoop important? So there are like a lot of aspects that we need to consider. So using Hadoop, we can store and process huge amounts of data very quickly. For example, if the traditional software is taking some 10 minutes or 10 hours, the time can be reduced even to 1/100th of the total time taken. So the computation power is very fast, and another main advantage is fault tolerance. For example, you have a Hadoop node of 10 node of Hadoop cluster. Even if 2 nodes, another 8 node will have the data. So the availability of data is higher. Even if 2 node is going down, your business keeps on running without affecting anything. So low cost. For if you consider other traditional softwares, it incurs like a lot of licensing cost. For example, for using Oracle or support cost of MySQL is quite costly. But Hadoop is more of an Apache-based open source license product, which comes completely free. It doesn't need a sophisticated hardware or software. You can just use low-end commodity servers. And another aspect is scalability. Scalability in the sense, I talked about X scaling and Y scaling, right? So Y scaling is as and when your business grows or data grows, you just add physical nodes to the existing server. So it doesn't need any maintenance or restart. Just, everything happens in real time. So the advantage of Hadoop is cost effective, it is flexible, fast. So it's resilience to failure. Even if one node goes down, you can other nodes will be running, which ensures the high availability of the whole ecosystem. So these are the core Hadoop components: MapReduce, Yarn, distributed file systems, and common. So this is in wider aspect. I have classified the Hadoop ecosystem. So there are like, for example, if you consider the database aspect, you have like HBase and Cassandra. And for example, for querying aspect, for example, some will be comfortable in doing SQL queries. They can directly use Hive, and some will be more comfortable in a scripting kind of languages, right? They can use Apache Pick. And for doing machine learning and to implement supervised, unsupervised, different reinforcement algorithm. So Apache Mahout is an API or framework which supports machine learning capability for big data. So Zookeeper and Ambari is used for managing and monitoring the whole Apache Hadoop ecosystem. So when to use Hadoop, right? So Hadoop will work only with the large data. For example, if your business needs to deal with huge amounts of data like petabytes, terabytes of data, then Hadoop is the best choice. For example, if your business needs to process like less amount of data and needs a less infrastructure, then you don't need a Hadoop ecosystem. So if you want to, and another important use case is if we want to do large scale extract, transform, operation process across a huge cluster, then Hadoop is the best choice. The same for aggregation also. For example, you want to do some sort of aggregation calculations across multiple large data sets, then Hadoop uses the Hadoop will consume less computation power, so that aggregation will be faster. So in that scenario, you will use the Hadoop. Thank you very much. Thanks for watching. Now I will show some real-time examples of the big data solution that we come across on daily basis. So this is my Amazon account. So actually, I'm interested in buying the Bluetooth speaker. So when I buy Bluetooth speaker, it does recommend a couple of other products related to the Bluetooth. It could be a similar product or similar devices, or it could be even different category based on the combination, something like an Amazon Alexa smart assistants, etc. So another interesting example is Google's recommendation. For example, if I want to know the review of any specific company, I would like to know the review of the company Cognizant. So I am typing in Cognizant review. I am getting the search result from Google, and it displays the review about the Cognizant. Along with the review, it also does some recommendation, like, is it good to join Cognizant as a fresher? Why is Cognizant best? Is it safe to join Cognizant 2019? So all these are the recommendations and predictions based on the user search. So this is one of the classical example of using big data, and how Google is leveraging big data to achieve various recommendations and search queries. So another classical example is using Amazon Prime. So this is my Amazon Prime account. I watched a couple of Tamil movies and thriller movies before. I too watched a couple of action thriller movies. So based on my watch history and my interest, Amazon Prime does some interesting recommendation. Amazon has all the user data and it does some recommendation. You can see the recommendation in the screen. Not only it does recommendation and predictions, it also does some interesting stuffs like sentiment analysis based on the user data, especially if you consider the movie. So based on the review comments provided by the movie reviewers or movie watchers, IMDb does some interesting stuff on sentiment analysis, and it just gives the rating of the movie. Here I am in IMDb website. So it considers the rating of around, you can see the data of the movie John Wick. Around 5,13,000 users provided the review for the movie John Wick. So based on that, they have rated like 7.4. To process all the data from the user and do the sentiment analysis, they use a big data system. Even Indian government railways department does the prediction. So based on, for example, if your PNR number is waiting list, it does some interesting stuff on prediction and alert user on the availability and the confirmation for the ticket. Prediction on the probability of the confirmation. For example, if you booked any ticket under the waiting list, interestingly, it runs some machine learning algorithm on the data, user data, especially the past users' travel history, and does some predictions on the confirmation. So you can see the predictions given by the IRCTC. You can find these informations in the rail website. As and when you book the ticket, if your ticket is in the waiting list, it apart from the PNR number, it also there is a field which will talk about the probability of confirmation. So that actually works on the big data ecosystem and runs machine learning on top of it and gives the probability of the confirmation. If the probability of confirmation is more than 80%, it is, there is a high chance that, you will get a confirmation of the ticket. If it is lesser than 40%, which means like, your ticket is kind of cancelled. Yeah. Thanks for watching. Over to Logeshwari.
Thank you, sir. That was very interesting and informative. Now we have come to end of the session. On behalf of Tagore Engineering College and CSE Department, I thank Mr. Deepak for sharing his knowledge and valuable time with us. Also, I'm glad to thank all the participants for their valuable presence and support that is to be appreciated. Hope you all give the same response for all the future webinars. I conclude the session now. Thank you.
Yeah, thanks everyone. Bye.